Hello and welcome back. So today we'll be making Conway's Game of Life. So if you're not familiar with it, you can go watch the Coding Trains video on it, or you can simply look at the Wikipedia for it. So basically, it's a grid of cells. Each cells will be either alive or dead, and their current state will change depending on the other cells around it. And let me go to a whiteboard and explain it a little bit better. So, alright. So we have our canvas, right here. This canvas will be divided between cells in a grid like so. Give me taking a bit of time. There you go. Awesome. So each of those cells will know if they are alive or dead, right? So let's take this cell, for example. So this cell over here will be, let's say 0 is dead, right? So 0 is dead, 1 is alive, okay? And each cell in here will be either alive or dead, and then there is a concept of generation. So let's say that each frame of animation is one generation. So on the next generation, there is 3 rules for all of the cells, right? So the first rule, let me check it up because I don't know by heart. Any cells with fewer than 2 live neighbors dies. Okay, so if neighbor, and I'll say n equals alive neighbor count, right? So if the number of neighbor is fewer than 2, right? So less than 2, right? You die. That's good. Or you're already dead. That doesn't matter. Any alive cells with 2 or 3 alive neighbor. Okay, so alive, and n is 2 or n is 3, then alive. So you stay alive if you have 2 or 3 neighbors that are alive. Number 3, any alive cell with more than 3 neighbors dies. So if you're alive and more than how many? More than 3, right? That makes sense because 3 over there. And neighbor is more than 3, then you die. They say from overpopulation. And the last rule is for creating new alive cells that were not before, right? So any dead cells with exactly 3 neighbors becomes a live cell. Okay, so if dead and neighbor equals 3, right? So these are our rules. Rules for cells, right? So these are the rules that we want, and this is per generation, right? So let's say this one is dead, and we have this one and this one and this one that are all alive. In this case, since let's say we're looking at every cell and now we're looking at this one. Since we'll look, first rule, not applying. Well, I mean, n is less than 2. That's not the case, right? We have 3 alive neighbor. N is equal to 3. It's alive. No, it's not alive. It's alive. No, it's not alive. It's dead. Okay, yes, it's dead. And n is 3. Yes. So next iteration, this will be 1, right? So that's pretty much the idea behind the Game of Life by Conway. So let's try to implement this in processing. Let's get it back over here. Awesome. So let me get here. Okay, so we'll have a setup function. Setup. Awesome. We'll do. So let me think. We'll need some grid size. So we'll need a scale for each cell. Let's call this SCL. Let's make it 30, just because we might want to click on it, right? So let's say 30, right? For the scale. And let's say we want. Yeah. Okay. That's fine. So let's say we will have also int calls and int rows. Cool, awesome. And we'll do 600 by 600 for right now. We can put it full screen afterwards. That's fine. Awesome. Okay. So we will have we will have sorry. Yes, we will also need an array, right? Do we want? I'm just thinking, right? So we could just do columns times row plus columns times row times x plus w. Yeah. Columns. Yeah, let me just comment that. Columns times y plus x. Right? Does that make sense? I'm not sure. Anyway, we'll do a 2D array just because. Yeah. So we'll have an array of cells, and it'll be an array of array, right? And we'll call this cells. That's fine by me. So yeah, I know cells not defined. We will eventually define it. Let's do it right now. Why not? So call this cell. So a new class that we call cell. This class will have a constructor. What do we want to put inside of it? We'll have the state, which will either be 1 or 0. I'm just doing this so like boolean state. It won't even be 1 or 0. It'll be actual boolean. Okay, that's fine. What else do we want in here? We might want. That's pretty much it. If I'm thinking of something else, I'll add it. For right now, I'm not. We might want to get. Let's do a function that returns a cell called next. So this will return us the next generation of cells. It will be passed a cell array of 8 elements specifically, so all of the neighbors. It's called this cells or neighbor. Cell is fine. So we said the first rule was, let me get this to the other screen just so I can reference it while coding. Awesome. I mean, I have it on the whiteboard. Yeah, I have it on the whiteboard. It doesn't matter. Okay, so first rule. So let's make the count of a live neighbor, right? So int, and we called it n, so let's just keep it as n. So n by default is equal to 0. There's no live neighbor. Let's do then for each cell in cell, right? So for int I is equal to 0, I is less than cells.length, I plus plus, there we go. And let's do if, let's put the curly brace. I like the curly brace. They're not bad for your health. Okay. So if cells index I dot state, state, then we can just do n plus plus, right? Awesome. So that's, there we go. So we have everything we need for the first rule. So first rule. So first rule, state any alive cell with fewer than 2 neighbors dies. Okay, so if this dot state, so if we are alive and n is fewer than 2, so fewer than 2, we die. So return, return new cell, cell, and let's make a different constructor, right? So let's make a constructor that receive state. Awesome. This dot state equals state. Cool. So a new cell that is dead, so false. Okay, great. So next rule, and next rule. Second rule. If you're alive with 2 or 3 neighbors, you stay alive. So if you're alive and you have either 2 or you have 3 neighbors alive, then you stay alive, right? I think it's THIRD. I don't know. Then, next rule. Any alive cells with more than 3 neighbors dies. So if you're alive, that's fine, and you have more than 3 neighbors, you die. That's fine. And fourth rule. Any dead cell with exactly 3 cells, 3 alive neighbors lives then. So if you're dead, so not state, and you have exactly, I said 3 neighbors, you now become alive. And let's by default return null. We don't expect to get to here, never, but yeah. Okay, awesome. So pretty much done for the cell. I'm thinking we could have a show function. We can have the x and y value. I mean, it doesn't really matter. X, y, it'll be a float, or it might be an int. I don't know, but float is fine for now. We'll change it to an int if we need it. Yeah, do I care to have this in here? I actually don't for the moment. I'll add it if necessary. Oh, awesome. So the cell is done. Now, let's create our grid. So we'll have columns. Columns will be equal to the width divided by the scale. That's it. Both of those are ints. So if we have like a like a number with decimal from that division, it'll be floored down. And same thing for the rows. So from the height divided by the scale, right? Awesome. Cool. That's great. Okay. We can just create the cells now. Let's create them all dead for the moment. So we'll have for int I is equal to 0, or let's do x is equal to 0, x is less then the calls, x plus plus. I mean, we could do I and j, it wouldn't really matter. That's totally fine. Okay, and let's do the same, but with y in this case, just because I've gone with x for the other loop. So awesome, awesome, awesome. Cell index, we first need to set this cell index. Well, no, yeah, my bad. Let's do cells equals new cell with calls and rows. There we go. Now we should be able to just do cells index x, index y being equal to a new cell, and it's going to be dead by default, which is our current behavior for the state. Yeah, awesome. Okay, now what we can do, what we want to do, is have also another array of cells, but this will be the next generation of cells, right? Right, yeah. This will be the next generation because we don't want to update the cells while looking back at neighbors that have been updated, right? So I don't want to update a cell based on neighbors that were updated. I want the original one and creating the new cells based on that one. So I'm going to do exactly the same as this here, but it'll be next cell. Next cells, awesome. And it's going to be the same size, same everything inside there. So here it's going to be exactly the same. So it's going to be next cells. Awesome. Great. Now in the draw loop, so void draw. What do we want in here? We can maybe display the cells. That could be nice for anyone looking at it. I mean, just looking at nothing is not really appealing to me, so we'll draw them. We'll do a background. Maybe black this time. Awesome. Now let's just make sure it does render something. It does. That's great. Awesome. So in here, we'll just do okay, we'll do no fill, or I mean, we could fill it, right? Yeah, that's fine. Okay, so let's do no stroke though. And let's do that inside of the setup function. It's fine. Okay, great. Awesome. Okay, so we will have a rectangle and we will have a fill, right? So the fill color will be based on the state of the cell. So let's call cell C or cell equal cells. If I can type, cells X, Y. Awesome. So we'll do if cell dot state. If it is alive, then we will do white cell 255, not 66. Otherwise, if it's dead, we'll just do black. That's fine by me. And then let's do a rectangle from cell. Well, from X times scale, Y times scale, and then let's do, let me, sorry, just thinking, let's do scale and scale, right? So this should still be all black. Awesome, it's working. Okay, great. So this is kind of the showing of the cell, right? Okay, now we need to gather all of the neighbors for this cells, let's say. And what I'm thinking is, in the case that this were, like, let me go back to the whiteboard. Okay. gonna take a different color. Alright. In the case that we want to get all the neighbors of this cell, for example, we would need neighbors that are over here, right? Which technically should exist because it's technically an infinite grid, but I don't want it that way, so we'll do as if they were all zeros, right? As if they were all dead. So we will, if we're out of the edge, all of those neighbors are just dead already. And those are going to be the only 3 possible neighbors for that cell, technically. Okay, yeah, that's fine. So let's go with that. Awesome. So let's gather up the neighbors, right? So let's do cell, an array of cell, call it, what do we want to call it? Neighbor maybe? Yeah, I guess neighbor is fine. So neighbors maybe, that might be a bit better. A new cell array, that's it, of 8, yeah, my bad, of 8. Okay, and now we'll do eight time neighbor. Whoa, what? Neighbor index and then equals cells cells at xy, right? X, it won't be xy, but it'll be something like this. Awesome. So let me duplicate this 8 times. Whoa, not what I wanted. There we go. Okay. Let me do this 8 times. So 1, 2, 3, 4, 5, 6, 7, 8. So here, this is going to be 7. This is going to be 6, 5, 4, 3, 2. There's maybe a better way to do this. Right now, I'm just doing it like this. So let's say I want the top left neighbor. It's going to be -1, -1. And let me do something like, this might be ridiculous, but I mean, let's do a function to validate x and y. Yeah, sure. It returns an int. Validate x. It's basically going to receive some x, and basically going to return if validate xy. Who cares? No, validate x. Yeah, sure. Well, no, validate xy. That makes more sense. X, y. If x is smaller than 0, or if y is smaller than 0, and let's it return a boolean. So if x is smaller than 0, or if y is smaller than 0, or if x is greater than or equal to cols, or if y is greater than or equal to the rows, return false. So return not all of this. I think that makes sense. What's the issue? Syntax error, invalid character. I've got this a couple of times before. Let me paste this somewhere else and copy it back. There we go. It's not. Okay, so we'll have validate xy every time here, right? So validate xy, then this, right? So let me remove all of this and we'll do it back again. Or new cell. Yeah, okay. So validate xy is basically going to tell us if we can use those xy, meaning if it is in the grid. If it is not in the grid, it'll basically just return, validate will return false, which means we'll go to this else statement and create a new cell, a new dead cell, right? So let me duplicate this a couple of times and we'll go through them. So neighbor 1, 2, 3, 4, 5, 6, 7. Awesome, I got the right amount. Okay, so -1, so this is the corner left. The middle one, it should just be x and it should be y -1. So x, y -1, x, y -1, okay. And then the top right, so plus, then let's go in a circle. So, and then after this, we're already plus, so we need to go y. And then here it's going to be plus, and then we want plus again and y at plus. Yeah, y at plus, and then we want y at plus, x as nothing, and then we want x as minus, y at plus, and then we want x as minus, y as nothing, right? I believe those makes sense. So let's just do the same here. Here, this is +1 minus, +1 minus. Here, +1 and y. Here, this is plus, plus. Okay, this one is x and plus y. This is minus and plus. There we go. And this is minus and y. Okay, I think we've got all of them. Awesome. So we got all of the neighbors. Cool, great. So now we want to call, we'll have cell, and this is going to be next cell. It's going to be cell dot next, passing it the neighbors, right? I think so. Okay, great. And then we just need to, yeah, we just need to set well, I mean, we could just do next cell index x and y equal to this, but it'll be actually next cells. Okay, and then the only last thing we need to do is over here. We need to update this so that next cells are now next, and next is just empty, I guess. So cells is now next cells, and next cells, I mean, it doesn't need to be empty. It can just stay whatever it is, right? It'll get overridden anyway, so it's fine. Okay, I think we're pretty much done. Let's just make sure it runs. There's some issue. Can't read field state because cell index I is null. Cell index I is null. Cell index I, would it? What line is it? game of life cells.next line 90. Well, I don't believe it's line 90, but I'm pretty sure it would be somewhere in here. Right, this cells index I is null. That's weird. Oh, it might be because cells is already defined over here. Maybe. Let me do instead. Yeah, that's possible, I guess. Let's do C just because it's not liking it. No, still same issue. Why is this happening? C, an array of cells. It's calling next. I'm calling next with neighbors, which is an array of cells, right? So let's print neighbors. Let's see. So print ln neighbors. Oh, neighbors. There we go. I mean, we're close to it. We're almost done. Okay, great. Let's see. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 elements, but then we have a null value in here. Why do we? Why do we have a null value in there? So this should be the middle cell, middle top cell, right? So let me print X and Y over here. Print, let's do Boolean value. Print ln X %d, I believe, and then Y, or just a tab, Y %d X comma Y. This should be fine, I think. And then let's do value as well. Comma, no, not comma. Backslash T value, well, value equals. How do I do a Boolean? Maybe it's a B, I don't know. Does that work? I don't know. Let's see it. Okay, great, awesome. So this one is fine, we already know. And then this one. Make sure X is -1, so it's false. This is fine, it's false. This is the second one. This is the one that we don't like. So X is 0 and Y is 0. This is not right. Because I said I want the middle top one. Why is Y 0? Y shouldn't be 0. Y should be freaking why is Y 0? I'm really questioning myself. Oh wait, no. I think I want the other way around. So this should go there. Same issue. What's going on? Let me come back. I'll be right back. Alright, so we figured out the issue.
The main issue was that I was referencing the same array, right? The same array in memory. So when setting the next cell, so I just create a temporary list array and then set that instead of setting directly to the cells. Then also I was getting another error. I'm not sure if this is the proper solution, but we'll see, which was this was not getting through any of the if at some point and was returning null, which was there just before. So now I'm returning like a dead cell for right now. We will see if that is the solution. Not 100% sure, but we'll see. So let's also take a look at the processing references for mouse press. Mouse called once after every time mouse button is pressed. That's fine. What is value, right? Well, no, that's fine. That doesn't matter. Okay, so mouse press. We'll use that to switch manually the cell's state. And we will say also, we'll have a boolean called running, which will be false by default. So running will be false by default, and we will basically do, well, we can do all of this. The only thing that I don't want to do is over here. Basically all of this can be moved to over here, and all of this is only if running. Cool. Awesome. And we'll do, this function could be better. It could be like get cell actually, but I'll leave that for you. So we'll have a function called key pressed, void function, void key pressed. This will be called whenever a key is pressed, and we'll do if key code is the space bar, which is 32, I believe. We will do not running is not equal to running. Awesome. And we will have void mouse pressed. There you go. And we will do int x equal mouse x divided by scale. And we will do a floor of this. I'm just not sure if mouse x is an integer or if it's a float. We'll do the same for mouse y. And though this time it's going to be y. And we will say that cells at index x, index y, dot state equals not what it is currently. So the inverse of what it is currently. Okay, let's save this. Let's see. Let's run this sketch. Okay, if I press spacebar, it's not doing what I want. It's actually really weird. This is happening. I'm pretty sure it's because of over here, right? Let's make a copy function. Copy cells. It'll return cell and it'll be copy. I'll just call it copy or copy cells. Cool. It will take in an array of cells, call this C, and it'll just go through all of that. Yeah. For int x equals 0, x is less than c dot length, x plus plus, for int y is equal to 0, y is less than c index I dot length. We could do calls and rows, that's fine. Calls, rows, y plus plus. It might not be due to that, but I'm pretty sure it is, right? Yeah, I mean, sure. Okay. Oh, maybe we could technically just let me comment this out. Let's go over here. Let's duplicate this line and let's do next cell is equal next cell dot state is equal to cell dot state. What's the issue here? Cells. Okay. Let me see this. Yeah, okay. There you go. So now it's working. Why is it not stopping? Oh, I'm guessing it's because, yeah, okay. So we will keep this function in the end. Yeah. So let's just create a copy equal to a new cell calls rows. Sure, and then we'll do copy index x index y is equal to cell to c index x index y. There we go. New cell, and this will be dot state. Not the most efficient for sure, but you can improve it. Awesome. So we'll use copy cell and we'll just do cells is equal to copy cells of next cells. And we don't need this temporary anymore. Okay, let's save. Let's see if this works. Yeah, awesome. So we're pretty much completed with the sketch. Let's make it full screen and try it out. All right, let's see. So I'm going to show you again this. So we can see there is examples over here. So I just did the oscillator. Let's do the spaceship. So it's an L shape with a single one alone, right? So an L shape, we said, with this over here. It should go in diagonal to the bottom right. It does, that's great. There you go, awesome. Let's try another one, just for the sake of it. So we have, these are complicated. Let me do something simple. 2 squares. Great. That I can definitely do. Seems to be working. The generations are going by really quickly. So what I'm thinking is maybe only do all of this. Only do it. Only do all of it once every 10 frame, right? Yeah, sure, that's fine. So let's do if frame count, I think, is modulus of, we said every 10 frame is equal to 0, then if it's not equal to 0, let's just return. Let's do an early return. There we go. Awesome, let's see it. So Oh yeah, I get what's going on right now. Let's move this also over here. And we could change the frame rate instead. It's fine. There we go. So it's running well, I think. Let's try it out again. Let's do this. Yeah, awesome. So we're done with the game of life. Hope you have fun. Play with it and let me know in the comments what you think of it. What can be improved. I mean, there's so much that can be improved right now. But play with it and have fun with the sketch. Great. Thank you. See you in the next one.